Now we are going to study about the topic motion under gravity. So before coming to this topic, we should have completed the study of equations of motion. There, equations of motion we have used in horizontal direction. In this motion under gravity, the motion of the object is in vertical direction. An object can be dropped from certain height or an object is thrown upwards with some speed. So in these two cases, that is the motion, equations of motion. How to use these equations in this case, we are going to see. First, let us recall the equations of motion we have seen. V is equal to u plus at we have seen. Second one, v square minus u square is equal to 2as. And third one, s is equal to ut plus half at square. And fourth one also, a special case, Sn is equal to u plus a into n minus half. These equations of motion, when we are using under motion under gravity, just we have to replace the acceleration with g value. Because when the motion is in vertical direction, the object is under the influence of gravitational pull or gravitational force. Because of that force, the acceleration must be fixed, that is equal to g value. But here, when the object is going upwards or when the object is coming downwards, there are two different directions. That's why the g value we are taking as either plus or minus. Whenever the object is going upwards, we are taking as acceleration is equal to minus g, whereas the object whenever it is coming downwards, we have to take the acceleration as plus g. So with the replacement of these values, let us rewrite these equations of motion in the vertical direction case or in motion under gravity. How the equations of motion converts? If you see, v is equal to u plus at, we are rewriting as v is equal to u plus gt. Second equation, we are writing as v square minus u square is equal to 2g. Since vertical displacement, you can take it as height, you can write it as h. Similarly, third equation, you can write it as h is equal to ut plus half gt square. And fourth equation, we can write it as Sn is nothing but, you can write it as height covered in nth second. Hn is equal to u plus, now a value becomes g into n minus half. So we can rewrite those equations of motion in motion under gravity like this. And before entering into discussion, just some points to be observed is, when the object is dropped, if we say when the object is dropped, then we should know that u value is 0. Similarly, when the object reaches its maximum height, but means at maximum height, speed should be 0 at maximum height, but acceleration should be equal to plus g. So this condition should be directly taken. I am writing this, speed is 0, acceleration is equal to plus g, because while reaching the maximum height, at this height, the object is stopped. Because after reaching maximum, it should come back downwards. That's why here speed should be 0. Next, whenever it is in the next instant, it is going to fall downwards. That means downwards acceleration always we are taking as plus g. That is why acceleration we should take here plus g. Like that, some terminology when the question given, in that question from the words directly we can take the values. Now let us see the situation here. Let us consider one situation where right. Now I am giving you one situation here. An object is dropped. At what height it is dropped is not given. So case 1 I am taking as If height not given, then what we can calculate the values here, or what kind of questions we are getting here. Let us observe. An object is just dropped from certain height. Height value not given. Dropped means immediately we should know that u value is 0 and acceleration should be plus g. These values we know. Then after 1 second, how much distance the object is travelled? Or after 1 second, what is the velocity obtained by that object? See here, what is the velocity obtained by the object after 1 second? How much distance it is covered? If you observe here, to calculate velocity after certain instant of time, now we have the equation that v is equal to u plus at, right? That means v is equal to u plus gt in motion under gravity. Now this, since the object is dropped, you can take a u value 0. That means v is equal to gt. We should know that what is the velocity after t seconds he given. So after t seconds, that means an interval of time he has given, not the instant of time. Anyhow, here we are going to calculate velocity. That's why directly t value you can substitute in this equation. So this is the equation we have to use to calculate after t seconds how much velocity an object getting. I told that after 1 second, how much speed we are getting? G value 10, t value 1. That means the object is gaining 10 meter per second. After 1 second, when it is dropped, at what height means? Height not given. Whatever the height, if the object is dropped, immediately we should understand that the object gets 10 meter per second after 1 second. After 2 seconds, how much? V is equal to 10 into 2, 20 meter per second. After 5 seconds, V is equal to 10 into 5, 50 meter per second. So directly after the time given, we can use in this formula t value directly substitute and multiply with g value. Corresponding speed obtained after certain interval of time, we can get it. After certain interval of time, once again I am telling you, not at that instant of time, a particular distance travelled or any other parameter to calculate, it is not the situation. Directly after certain interval of time from starting point. This is the equation we have to use. Distance if we calculate, see s is equal to ut plus half at square. Here we can understand the importance of what is the interval of time or what is the instant of time. See here, this equation we have to use for interval of time. From starting, how many seconds? For that case only we can use this equation. At a particular instant, that means at a 4th second or 10th second, particular instant of time if it is given, we have to use this 4th equation. Fine. Here, in this case, u value 0. Dropped case, that means the distance is equal to half, and while falling acceleration value g we are taking half gt square. Directly we can use this formula. How much distance after dropping an object getting? So after 1 second we calculated speed. At this, after 1 second, how much distance covered? If you see, s is equal to half 10 t square 1 square. That means 10 by 5, 10 by 2, this is equal to 5 meters distance. Is it? After 1 second, an object, after 1 second of dropping, we are getting 5 meter distance. After 2 seconds, how much distance it travelled? Half, g value 10, 2 square, 4, that means 2 to just 20 meters it is travelled. After dropping, after 2 seconds, 20 meter distance covered in vertical direction. After 5 seconds, or let us calculate after 3 seconds. Half, 10, 3 square is 9. That means this is 45 meters travelled after 3 seconds. We can just remember these values because here, at what height the object is dropped not given. That means general case. We can directly remember the values. It is much useful for us. If a particular height given, at every height we have to calculate separately. But in this case what happens, irrespective of the height from where the object is dropped, these values are constant, they won't change. So directly observe these two equations. In this case it is much useful for us for the better analysis. Next case, when the height is given, observe how to calculate or what are the type of questions we are going to get in case 2. When height given, so when height given, what happens? From certain height object is dropped. After 1 second, how much velocity it will get means same thing we can apply. Because height doesn't matter for us. This velocity we calculated independent of the height. And how much distance traveled also independent of height. These two questions asked means after whatever the height given, we can directly use these values only. What kind of questions we are going to get means when height is given, how much time to reach the ground they will give. Then we can check. If 1 second, 2 second, 3 second exact value is there, from this directly we can answer that. Otherwise, other values are there because, for example, 5 meter, 20 meter, 45 meters, we know how much time it will take, 1 second, 2 second, 3 second. If it is not dropped from these heights, then they may ask, how, at a particular 25 meters or 30 meters it is dropped. For example, let us take, when it is dropped from a height 30 meters, then what they may ask the question is, from 30 meters object is dropped, what is the time to reach the ground? Or what is the velocity when it is touching the ground? So these questions may be asked. Time to reach ground, or velocity when touching the ground. Let us calculate these two with respect to this case. I am showing now how to calculate these values. So first question, time to reach ground, it is dropped from 30 meters I told. So from 30 meters it is dropped. Dropped means u value 0, acceleration value plus g we know. Now while touching ground, how much time taken? First, here time is there, u is there, initial speed is there, height is there, acceleration is there. The suitable equations of motion we have, s is equal to ut plus half at square. From this equation, if you substitute the values, u value 0 here, that means first term 0, half, a value we are having g, nothing but 10. I am taking the approximate value of g until and unless given in the question, a value, acceleration due to gravity, g value equal to 9.8 meter per second square. Let us use the approximate value 10. So that t, how much we don't know, so t square, s is equal to this much. So that it is, s is equal to here how much given, 30 meters given directly, you can substitute. 30 meters is equal to half 10 t square. So t value how much? First of all, t square value, 1 0 cancels, 6 directly. T square is equal to 6 means time value root 6 seconds. We got time with the help of this equation like this. And similarly, velocity when touching the ground. And at the same point, we can observe the general formula for this situation. We can take the general formula here. Whatever the height given, if time asked for this situation, what we can write, observe. Here, from this equation, t square is equal to 2 into height given divided by this acceleration value g, or t is equal to simply root over 2h by g. This formula you can use directly to calculate the time when height given. But I suggest you generally direct equation given, directly this equation if you substitute the values also, same time will take to get the answer. Instead of remembering more number of formulas, I suggest Directly use basic formula. Fine. Whenever velocity while touching the ground, we need to calculate which equation we can use. Here I need now velocity how much. So initial velocity, final velocity discussion. Height given v u s. This related equation is v square minus u square is equal to 2as. Let us consider that equation. V square minus u square is equal to 2as equation. If we use, we can get the velocity when touching the ground. So from this equation, if you observe, v square we need, since dropped case u value 0, directly I am writing is equal to 2as, 2 into g value 10, s distance or height given that 30 meters. So that v square value we are getting that 600 we are getting, or from that v value root over 600 meter per second. Like that, in motion under gravity we are getting two basic different cases. Let us discuss some more situations.